I am Ananyashree from KIT Polytechnic and Civil Branch. I am going to discuss about some portion of the concrete technology. That means the chapter of phrase concrete. Okay. So there are some properties of the phrase concrete. Before going for the properties, first what is phrase concrete? As we know, concrete is a mixture of binding material like cement and fine aggregate like sand and coarse aggregate like gravel, all and proper amount of water and proper proportion of water, then the cement is concrete is formed. Okay, phrase concrete means when we are preparing concrete and it is in the form of phrase state, it is called phrase concrete, and we can call it as green concrete also. Okay, so these are the properties of a phrase concrete. When we are preparing the concrete, these are the properties. One is workability, second one is free from segregation, third one is bleeding. Then what is workability? Workability is nothing but the ability to work. That means when we are preparing a concrete, it has the tendency we have to make it in a beam form, in a column form. That means we have to give it a proper shape. That means workability, the total process. Okay, from the starting, that is when we are mixing the concrete paste to the placing and finishing, total preparation part is comes under workability. Okay, next one is segregation. Segregation means if the concrete we are transporting the concrete from one place to another place, there is a chance of separation due to some vibration and any other, due to placing, improper placing also there is a chance of segregation. Segregation means the separation of the materials, any of the constituent like some amount of sand, that means the mixture or the any gravel or the coarse aggregate we are using, it is separating out from the rest of the constituent of the concrete. That is the separation, segregation, or it is called as the separation of any of the constituent from the rest of the part of the concrete. Next is bleeding. Bleeding means the separation of the cement paste or the water portion. If the water comes out over the surface of the concrete, then it is called the bleeding. Okay, here I am describing the workability is defined as the ease with which concrete may be mixed from the mixing to the finishing portion, mixed, transported, placed in position and compacted and finished. That means the total process, if we can do properly, if it is performed properly, then it is called the workability. That means the workability of that concrete paste is good. Then second one is segregation. It is defined as the separation of the ingredients of the concrete. That means there is some ingredients like cement and sand and coarse aggregate. If coarse aggregate is separating out from rest of the mix, it is called segregation. Similarly, bleeding is also one type of segregation. Segregation is not bleeding here, but bleeding is one type of segregation, because in case of bleeding, it is defined as the separation of the water gets deposited over the surface of the concrete. That means if the water with mixture of cement, when the water comes out over the surface of the concrete, it is due to the improper water cement ratio. That means if the water percentage is very high in the concrete, then some amount of water is deposited over the concrete surface, then it is called the bleeding. It is also one type of demerit. Okay, this is, you can see in this picture, this is the one type of segregation part. When we are placing the concrete, or when we are placing the concrete for a column or any type of structure, if we are properly not placing the concrete, there is segregation. That means the cement paste is separating out and the aggregate is also separating out. So that this is one type of segregation part, and this is also one type of bleeding. You can see this is the bleeding. That means the water paste coming out over the surface of the concrete. Next, some factors are affecting the workability concrete. That means the workability affected by the water content. First part is your water content of the concrete mix. That means the water cement ratio. If there is improper amount of water, water content will have important influence on the workability in given volume of concrete. The higher the water content per cubic meter of concrete, the higher will be the fluidity of concrete. That means in the water cement ratio, if we are preferring water cement ratio, if the water content is high, the fluidity should be high. Okay, so fluidity will be definitely high, so that the fluidity means the water content, the concrete has the fluidity power, so that the which affects the workability. That means water content is high, concrete is fluid, but the strength is decreasing. Okay, if the water cement is high, the workability is increasing, but the strength is decreasing. Similarly, here I am defining the strength of the concrete may get reduced. More quantity of water comes out from the surface of concrete, resulting into bleeding. And another factor is there, bleeding is also there. If the water cement ratio is high, the bleeding should be occur and the strength will get reduced. Okay. So next factor is the size of the aggregate. The aggregate that we are using in the concrete, it is also affects the workability. How? Workability is mainly governed by the maximum size of aggregate water and paste required will be not less if the chosen size of aggregate for concrete is bigger. Consequently, for a given quantity of water content paste, bigger size aggregate will give higher workability. That means if the size of the aggregate is large, that means it requires more water cement, more paste. That means the cement requires cement water and paste is required is more, so that the workability is low. But the size of the aggregate is less, the water cement ratio and the cement paste requires is very high, and if the bigger is the size of the aggregate, it requires the, if the size is bigger size, the surface area is low. Remember, the size of the aggregate has the lower surface area, but the size of the aggregate is low, then the surface area is high. If the surface area is high, it requires more cement paste, and if the size of the aggregate is bigger, then it requires less cement paste. Similarly, next factor is the shape of the aggregate. Angular, flaky and elongated aggregate reduces the workability of concrete. Why? Angular, flaky and elongated aggregates has the larger surface area. That means it requires high water cement ratio. Rounded or sub-rounded aggregate increase the workability due to the reduction of surface area for a given volume or weight. Therefore, an excess paste is available to give better lubricant. That means it requires less cement paste, so that rest of the cement paste is used in the to give the bond and proper strength. Rounded shape aggregate has less frictional resistance and gives a high workability as compared to the angular, flaky or elongated aggregate. Next is your surface texture of aggregate. The roughly textured aggregate have more surface area than smoothly rounded aggregate of the same volume. That means the roughly textured aggregate have more surface area. That means more surface area means it requires more cement paste. Okay. In case of smooth rounded aggregate, in the same volume it requires less amount of cement paste. Okay. Next is the porosity of aggregate. Porous and non-saturated aggregate will require more water. That means if the aggregate has the porosity, that means it requires more amount of cement paste. Okay. But in case of less porous aggregate, requires less amount of cement paste. Next factor is your grading of aggregate. Okay, if well graded aggregate is used, it gives better workability. Okay, if low graded aggregate is used, it gives less workability and it reduces the workability. Next is uses of concrete admixture. As we know that admixture is a better impurities that we can use in the concrete to enhance its property, that means workability property. If water cement ratio or water content is high, we can add admixture to manage to balance the water cement ratio. Okay, so it is also responsible to enhance the workability. Next factor is your temperature. In high temperature weather or hot weather, there is evaporation process takes place, so that the water, if we are adding water, that water evaporates very short in short time period, so that the strength gain will earlier strength we can gain in the concrete. Okay, so these are the factors which are affecting the workability. Next, the workability of concrete can be measured using the following methods. That means the workability of the concrete we can measure by conducting following tests. First one is slump test, second one is compacting factor test, third one is VB consistometer test, fourth one is flow table test, and fifth one is Kelly ball test. Within these 5 tests, first one is slump test, and which is widely used test for the workability measuring. Okay, so slump test we can conduct in laboratory and in field also. That's why it is widely used. So in this picture you can see, sorry, in this picture you can see there is a slump test apparatus. That means the slump cone. In slump test we are using this slump cone and this base and this rod. This is called tamping rod, and slump cone has the base diameter is 20 centimeter, top diameter is 10 centimeter, and the height of the slump cone is 30 centimeter. Okay, so slump test is the most commonly used method of measuring consistency of concrete, which can be employed either in laboratory or at site of work. It is not a suitable method for very wet or very dry concrete. That means the consistency, the water content should be proper to conduct this test. Okay. Slump cone apparatus. The slump cone apparatus along with tamping rod, that is tamper, which is 16 mm in diameter and 600 mm length. The tamping rod of rod shall be rounded at the hemispherical tip, ruler, etc. Okay, that means this is the tamping rod. The end should be rounded, okay, so that we can tamp the concrete layer. Sorry. Next is the procedure for the slump test. Before conducting slump test, first we have to prepare the concrete mix at the proper condition, and we have to maintain the proper cement water cement ratio. Okay, the internal surface of the mold should be thoroughly cleaned. That means that cone we are using, slump cone, that should be cleaned properly and freed from superfluous moisture. There should be no moisture and it should be dry. And any set of set concrete before commencing the test, the mold shall be placed on a smooth, horizontal, rigid and non-adsorbent surface such as a carefully labeled metal plate. As you can see, the base metal, and we are putting the slump cone over that, so that no loss of concrete should be there. Okay, the mold shall be filled in 4 layers. For that mold we have to fill in 4 layers. 1/4 of the layer we have to fill one by one, and one layer is tamped 25 times. Okay, we have to tamp by using that tamping rod 25 times. Okay, the mold shall be filled in 4 layers, each approximately 1/4 of the height of the mold. Each layer shall be tamped with 25 strokes of the rounded end of the tamping rod. The strokes shall be distributed in a uniform manner so that no voids are there. There should be no void in the layer, each individual layer. Okay. Similarly, we have to put the layers up to 4 label, and total we have to label the cone, slump cone. We have to fill the concrete to the concrete cone. Okay. The bottom layers are be tamped thoroughly throughout its depth after the top layer has been rodded. Okay. Similarly, we have to layer wise we have to put the concrete up to 4th layer, and we have to stock up the rest of the concrete over the slump cone. Okay. Next, we have to take the measurement. How we can take the measurement? After putting the concrete at its top level, vertically we have to reduce, we have to lift the concrete cone upward. Okay. Then first, as we know that the height of the concrete and height of the cone is 30 meter, then some amount of concrete should be settled down and some amount should be stiff. There is 3 cases are there. One is collapse case, one is type shear, one is true slump. That means when we are vertically removing the concrete cone, some amount of concrete that settle down. That means this height, previously we have recorded this height is 30 centimeter. As we know that the slump height is 30 centimeter. After removing the mold, it settle down. That means some height it reduces. That height is called slump height. That height we have to measure in the ruler. Okay. So that is there is the observations and recording. The vertical difference between the top of the mold, that is 30, and the displaced original center of the top of the surface of the specimen. Then this is the reduced specimen. This is the specimen after removing the concrete cone. Okay, slump cone. That means this height will be the slump value for the concrete that we have placed. Okay, this is the 3 cases that can be performed. One is collapse, one is shear, one is true slump. If the concrete within this height, concrete reduces the height within this is called slump. If this height is in medium height, it settle down, it is called slump, a shear slump, or it is called collapse. That means if the water content is very high, it will be collapse. If we are removing the concrete cone, it will get collapse. How we can record or observe the workability? If it has very low workability, then the slump should be 0 to 25, and it comes under unit or we can take it centimeter also, but we are considering it that height, that difference in height before and after. Okay, after removing the slump cone. The very low workability for 0 to 25 slump, low workability for 25 to 50 slump, medium workability is 50 to 100, and high workability is 100 to 175. Okay. So this is the observation we can take, and we are always going for the shear, because true slump is very steep concrete, and collapse, as we know that we have to add some plasticizer or any admixture to maintain that water cement ratio, but it is not preferable at all. Okay. This is the end of the video, and thank you very much for listening me.